Okay, so this is the last video over section 6.6, and really I'm just kind of going back and covering how to, oh gosh, the cat is here. What are you doing? If you don't believe me, there he is. Say hello. Say hello. Yep, you little jerk. You gotta get down. Okay. Uh-oh, no. He's coming now. He's giving me the evil eye now. Okay, I can't stop the video because I have to start it over again, so I need to distract him. Hold on, or else I'm gonna get destroyed. I'm sorry that I'm wasting your time with this. Here, go get your ball, idiot. There you go. Okay. All right, here we go. So I really just want to change from A plus BI to the R cis theta form and back. Okay, so we're gonna do a couple problems both ways. All right, so let's take -6 plus, we'll get real fancy here. Let's say the B is root 3. Okay, so instead of A plus BI, I've got -6 plus root 3i. Guys, really all you have to do is go back to our 4 pillars here and just graph this on the the complex plane. So the real number is -6. That means on the real axis, we're gonna go left 6. Okay, so that distance is 6. And then the imaginary part is root 3. So we're going to go up root 3, and then there's our point, okay? This complex number, we just plotted that number on the complex plane. It's not an ordered pair. It seems like it should be an order. It's not an ordered pair. It's just a number. We have plotted a complex number. This point represents a number, not a pair of numbers. This is one number. It is one complex number. It has 2 parts. But it's one number. You are one person. You are made up of lots of parts, but you're still one person. Just like this complex number is one number made up of different parts. Okay, so to find the cis form, all we need to find is the R, right? This is R, and then we need to find the theta, which is that standard position angle. Now the R is easy. We just Pythag it. So R is the square root of, square both sides here. Root 3 squared is 3, plus 6 squared is 36. That is the square root of 39, which does not reduce. Okay, for the theta, first we need to find this reference angle. So I'm going to call that angle x. And to find angle x, I just use tangent. So I'll say the tangent of x equals square root of 3 over 6. Now let's go radian mode here. Okay, so if I go radian mode and do second tangent of square root of 3 divided by 6, I get a reference angle of 0.281. So that angle x is 0.281. So to find theta, as you know, all we have to do is pi minus 0.281 because our angle's in the second quadrant. If we were down here in the third quadrant, we would do pi plus. If we were over here in the fourth quadrant, we would do 2 pi minus, but here we are. So we'll do pi minus that answer, and I get 2.86. So that's my theta. So the R cis theta form is easy. Here's my R, square root of 39. Cis, here's my theta, 2.86. That's all there is to it. Okay, no matter what that is, that's how it works. There you go. I don't really think I need, well, I'll do one more just in case you want. So let's say we have square root of 2 is the real number part. Let's make that a minus. Minus 3i. Okay, so I'll write that again. Root 2 minus 3i. And we want to change that to R cis theta form. Okay, so first, just kind of plot that point. The real part is square root of 2. That's positive. So we're going to go right root 2. The imaginary part is -3. So I'm going to go down 3 on the imaginary axis. There's our point. Here's our triangle. We need to find the R and we need to find the theta, okay? The R is easy, Pythagorean theorem. Square root of 2, if we square that, we get 2. 3 squared is 9, that's square root of 11. To find our theta, we need to find that reference angle first. So to find that reference angle, I'm going to say the tangent of x is 3 over square root of 2. We'll do this one in degrees since we did the last one in radians. So I put my calculator in degree mode, and I do second tangent of 3 over square root of 2, and I get 64.76 degrees. So to find theta, since we're in the fourth quadrant, we'll just do 360 minus that. And I don't feel like doing that in my head because I'm lazy, and we get 295.24 degrees. So there's your r, there's your theta. Your trig form is just square root of 11 cis 295.24 degrees. That's the polar form. That's the trig form. It's that easy, guys. You're just finding the hypotenuse and the angle. This is the exact same thing we were doing when we were changing to polar coordinates. Okay, let me show you this. Instead, let me see, make sure I get this lined up right. Move this up a little bit. Okay. Let's say instead of this complex number being root 2 minus 3i, let's say I had a set of rectangular coordinates, and the x coordinate was root 2, and the y coordinate was negative 3. And we wanted to change that into polar coordinates. We do that the exact same way we just did this. You find that radius, you find that angle, and your polar coordinates would be, the radius would be root 11, the angle would be 295.24 degrees. So if you remember at the beginning of all this the other day, I told you that this chapter was just applications of the same thing over and over and over again. So with polar coordinates, we called one coordinate the r and one coordinate the theta. With complex numbers, it's not r comma theta, it's r cis theta. They're different applications of the same math. You know, polar coordinates and complex numbers are not the same thing, but the math, the trig involved is the same. Okay, the next video is going to be going backwards, going from r cis theta to a plus bi form. I know I said I was only going to do one more video, but I'm trying to keep these short. So I'm going to do one more where we go backwards. Okay, bye, see you there.